You may have heard of ETL. That's been primarily how we used to do things in a batch world, which means we take data, we transform data in memory, and then we load it to some kind of warehouse. It's been the dominant approach for a long time, but recently we transitioned to ELT. So what is ELT? ELT just stands for extract load, then you do the transform later. So it's becoming more popular today because cloud storage is extremely cheap. So you don't have to worry about, oh, what happens if I just store useless data that I'm not going to be using today. It's cheap. Like you can store data on S3, for example, like 1 terabyte costs you $23 a month. So it's very cheap to store data. Whereas in the past, if you want to store more data, you run out of disk space, you have to call some kind of network or infrastructure engineer to come to your office and then plug in a new disk into your server rack. So it's very manual and very expensive. Oops, sorry. Let me just turn off my Slack. Cool. So for my talk today, I'm going to be focusing on ELT. Okay, let me just move this aside. All right, so ELT, let's talk about the first step of ELT, which is data integration. So as you can see there, we've got a couple of different data we want to integrate. So we got different data sources like APIs, files, and databases. So essentially, you imagine your company, you're going to have lots of different ways or systems that you guys use. You might have a database, you might have some kind of application you use that has an API attached to it. You might have some files like CSV, JSON files in some kind of file system you want to extract. So the whole point of data integration is how do we efficiently and without writing too much code, how do we move that into our data warehouse? And by data warehouse, I define it as just some kind of location where you're going to perform some kind of analytical processing. And it's a very key differentiator from a data warehouse to an application database. The big differentiator is that the kind of workloads you're trying to run is quite different. For an application database, you're normally concerned with transactions, like how do I read a record? How do I write the record? How do I update this record? So that's why in a transactional database, like an application one, it uses like OLTP and row-based storage. Whereas in an analytical database, we are talking more about like columnar storage. So we are not querying all the rows. We're just finding the exact columns we need, and then we can do some kind of analysis on the data that way. So you'll find like vendors like Snowflake, Databricks, Spark, BigQuery, they're all kind of trying to play in a space where it's a column-based storage and they have clusters to compute your data. All right, so now that we have data in the warehouse, what do we do with it? So this is where the data transformation side comes into play. So there are a couple of things we can do to the data. The first thing we can do is try to enrich the data. So when data comes in, sometimes it might come in and the format of the data is not very clean. So you want to apply some kind of like maybe renaming of columns, casting to a different data type. That's how we get data into that staging layer, right? And how many of you have worked with SAP before, SAP? Anyone use the German system? And notice the column names are in German, like different acronyms of German characters. So it's very, very hard to understand what those column names mean. So it's very useful to then rename those things into something that is more easier for the user to use. The next thing we do then is we then model that data. So we do some kind of modeling techniques, and there are a couple of them I'll kind of chat to you about. And then that's how we then get the data into the serving layer in our warehouse, which means it's ready for end users to consume. What kind of end users do we have? So there are kind of 3 different use cases I kind of group it into. So the first type of use case is what we call the analytics use case. So this is like the classic BI, dashboarding, answering business questions, ad hoc analysis type of use cases, where your business might have a question like how many customers do we have this month? Which regions should we target the next quarter? Things like that. You're going to be looking at your data warehouse, building some kind of dashboard or insight to give you the answer to your question. Another very new and popular up-and-coming use case is to push the data from your warehouse back into applications. So like think of it as like Salesforce. Like Salesforce, who are the users of Salesforce? It's your salespeople in your company, right? So it might be useful to then take some of the data from the warehouse, like maybe after you join some data, you've got more insights into what a customer does, and then push that data back to Salesforce to help your sales team make better decisions. So that's what we call the application use cases. And one of the very new kind of products in the market today is what is known as reverse ETL. So which is essentially a low-code way of pushing data back to those applications. And there are tools like Sensors and High Touch that does that today. And the last use case, I think, is everyone's favorite, machine learning. Everybody talks about it. So yeah, but the kind of key caveat here is that with machine learning, you have to remember that we are currently in a batch world. So all the data is not being updated every second. It's updated on some kind of periodic basis, like maybe once a day, every few hours. And so what kind of use cases can we support with periodic data updates? So there are two use cases I can think of. The first is training of models. We're not necessarily needing to train models every second. We're wanting to maybe retrain models when we feel like there's a bit of drift happening with our model data. So that can happen on a batch basis as well. So that's one use case. The second use case is batch inference. So maybe you don't need to predict data or predict the events or what the customer is going to do in real time. Maybe you want to predict it once a day. You do a big load and then just predict a bunch of things. So those are two common use cases you might see with machine learning. And the last piece of the puzzle to tie it all together, let's turn off my email as well. The last piece of the puzzle is data orchestration. So data orchestration is how we glue all these different components together so that we get a unified process happening. So in other words, data orchestration is going to be responsible for kicking off the data integration side. So let's run that on a certain time of day. And once the data integration completes, we can then run the next step, which is enrich. Then when that completes, run model, and that completes, then we can maybe even trigger off reverse ETL pipeline on sensors, or trigger off a machine learning training model, trigger off a dashboard refresh. So data orchestrator is responsible for doing those things. All right, any questions? I'm gonna keep it interactive. So if you do have questions, just shoot your hand up and we can chat. Anyone? Cool. If you do have questions along the way, feel free to just put your hand up and I'll pause. And also, is this all new to everyone, or is everyone here familiar with this stuff? So maybe give me a thumbs up if you're familiar with it, and thumbs down if like this is all new to you. Okay, it's good that most of us are kind of familiar, and good that we're here to teach as well. So awesome. All right, so the interesting bit, I guess, is like, all right, we know these basics, right? These are all things we're pretty familiar with now. The question is, what do we use and what key design decisions do we have to make when we're choosing a particular technology to use? So let's talk about data integration first. So data integration, the purpose, as I mentioned, is to sync data between source to destination. Now, the questions you should be asking yourselves when you're deciding on what tool to use is, what kind of connectors are supported with this tool? So connectors, when I say connectors, there are two types of connectors we need to think about. We need to think about the source connectors and the sync connectors. So source connectors are like, what kind of applications can I connect to? Can I connect to my Salesforce API? Can I connect to SAP data? Can I connect to this file system, S3 buckets, etc.? So these are kind of questions you have to ask. Those on the source side. And then on the sync side is where can I push my data to? So if you're using Snowflake, let's have supported connectors with Snowflake, etc. The other question is pricing model. So depending on the tool you use, the pricing could differ. Like for example, in Fivetran, they're going to charge you per record ingested, so usage-based pricing. Whereas something like maybe AWS DMS, it's more of a like flat fee. It's more of like you can manage your own servers if you want to as well. So if you're doing like high volumes of data, maybe it's better to go with more of a flat fee where you're managing your own infrastructure and you're not paying per record ingested. Whereas if you're more of a startup, you want to go fast, then maybe getting a SaaS product like Fivetran is actually better. Then the other question as well is extensibility. So not all connectors are going to be available from that tool, especially if your company wants to do something bespoke, like you've gone ahead and you built your own custom application and you have REST API endpoints that's custom to you. So there's no way that this tool like Fivetran will go and build a connector to your bespoke application. So you have to ask yourself, does this tool support building of custom connectors, and how easy can I build my custom connectors? So every tool has varying difficulty in terms of doing that. So try and see if you need to, find something that is easy to build. And last but not least is always support, right? Like, so if you're using any tool, what kind of vendor support can I get? So do we have a question in the chat? So the question in the chat here, what kind of complexity do you see with file system data when I have to train data model for ML? What's this there? I don't think it's that complex. I think it depends on your file format that the difficulty might change. So if you're doing like, if you're training models with very standard file formats like Parquet, then I don't think it's going to be complex at all. But if you're doing like, if your data is in XML, then maybe that's a bit harder to parse. Yeah, so it depends on the file format. Yeah, oh, good question. So what tools do we have available to do data integration? So here are just some tools listed in front of you. But the key thing I want to call out to you is the years in which those companies were founded. So as I mentioned to you, ELT is a fairly new paradigm. And likewise as well, these tools are all fairly new. So the earliest one I could find was 2011. But even then, I would say it's not the best tool in the world. The better ones are kind of the more recent ones that just released, like Fivetran and Airbyte. It's pretty good. Stitch as well, I hear good things about. All right, so let's take a look now at a live demo of one of these ingestion tools. So I'm going to jump into Airbyte, and I'm going to talk you through what Airbyte is. Show of hands here, how many of you have heard of or used Airbyte? One hand, two hands, three hands. All right, no one has said, okay, what do we use for data integration today? Like, just shout out a few tools that you guys use. AWS DMS? Yeah, what's that? Segment? Oh, okay, I shouldn't have said that thing. Okay. Fivetran, anyone? Yeah, Fivetran. Okay, cool. But yeah, so Airbyte, I like it because it's open source. I like open source products because I can look into the code. I can like run it on my machine. But yeah, here's Airbyte. It's very similar to all the other tools. It's not very different at all. So in Airbyte, I'm currently in the sources side. This is how I create a source connector. So to create a new source connector is as simple as clicking new source and then choosing a connector and then providing the connection strings. So Airbyte has something like 160 connectors to the source side. So I can pick something like, say, Postgres and just fill in the credentials, the connection string details to connect to that Postgres database. Likewise, same story on the destination side. Where do I want to land the data into? So I can click on new destination, and it supports all the landing databases you expect, like BigQuery, S3, Snowflake, Databricks, Redshift. Those popular ones are all supported. All right, so assuming now I've gone ahead and created something. So what I have for this demo is a mock database running my machine on Postgres for a fictitious DVD rental store. Those things don't exist anymore. I think it's all Netflix today. So yeah, very good example to be using. And for the destination side, I'm using Snowflake as my data warehouse. So once I configure the source and the destination, I just need to go and create a new connection. Connection is how you sync data from A to B. So I'm going to select my source and select my DVD rental Postgres. Click on, is it big enough? Maybe I should zoom in. Click on use, and destination is my Snowflake. Click on use. Okay, so what it's doing right now is it's actually fetching some metadata around my tables inside my source database. So what you'll see show up now is a list of tables that are in my DVD rentals database. Notice I didn't have to write anything to connect to it and then figure out what tables are there or specify the tables. So the way Airbyte is doing that is reading our information schema from Postgres and then inferring what tables are available and also what columns and data types are within each of those tables. So if I want to sync a table, it's just as simple as clicking on and off on this little slider here. So if I don't want to sync it, just deactivate. If I want to sync it, activate it. So what other settings do we have here? The other one that's important is the frequency. So how often do you want to sync the data? I'm just going to leave it as manual for now. I'll explain later why. And then the last thing here is which schema do I want to write my data to? And I'm just going to put it as SG Meetup for this demo. All right, then the other last thing we need to worry about is the sync mode. So sync mode is how do we replicate the data? And you can see here, there's two things we need to think about, the source and the destination. So I'll just flip back to the slides now to kind of explain to you what those things mean. So when we're trying to extract data from the source side, how do we extract that data? Do we want to extract it on a full refresh, meaning select all the records in the table that's on the source side, and then once we got all the records from that table in memory, what do we want to do with that? Do we want to overwrite the data on the target side? And so that's one sync pattern you can use: full refresh from the source and overwrite in your destination, right? And so this kind of diagram here kind of illustrates that point where, if you get new data, you're always just doing a full refresh anyways. There are other patterns as well, like incremental and append. So you can select only the new records that you haven't ingested yet from the source, and then append the new records into the destination. May not be the best because it doesn't really do updates. So if you have a record that's updated in the source side, it doesn't replicate the update, or the record that's deleted, it also doesn't replicate. So you just got to pick your pattern that works best for you. And there are other ones like dedupe, which is pretty much the update equivalent. But the one that I want to call your attention to is CDC. So again, show of hands, how many of you here have started using CDC? About 10 of us. If you haven't started using CDC, consider using it because it's awesome. CDC, what is CDC? So CDC just stands for Change Data Capture. What it means is that traditionally, we've always been replicating data by querying what's inside the table and then replicating that across, right? But the new kind of way we can approach things is to turn on Change Data Capture on the table, meaning that every time somebody writes some kind of transaction to your database table, like an update statement or insert statement, that transaction will now be stored inside a transaction log. So you have a full history of every event that occurred. So somebody inserted data, somebody updated data, etc. So that's better because now we can take that transaction log data. We're going to reach into that instead of the table. We're going to replicate that inside our data warehouse. And we can also replay the events in chronological order so that we get a representative state of what the table looks like in the source system. So this is just a diagram to kind of illustrate that. We got deletes and updates happening at source. Transaction log will have those deletes and updates. And then we replicate that on the destination table. And boom, we've got destination table that maps exactly to source. All right, I'm going to pause here. Any questions on data integration? That was the demo. Oh, actually, maybe what I'll do is I will just run a sync now to show you what happens when you use Airbyte. So I'm going to only select some of the tables I'm interested in and leave the rest out. So let's go with this. All right, and I can now just click on set up connection. All right, and where's the button? Sorry, Zoom is blocking the screen. Click on sync now. All right, so Airbyte's running on Docker on my machine, so it's going to kick off a whole bunch of different container services to ingest, to pull the data out from the source system. It should take about 3 minutes. But what we will see eventually is that if I go into Snowflake, this is my Snowflake instance. It's just a data warehouse. I should see a schema called SG Meetup appear here shortly. If everything goes to plan. Live demos are not always going to plan. Oh, some errors. Let's pretend we didn't see that. Okay, there you go. SG Meetup is now there. We should start to see some tables flowing in. So Airbyte syncs data into a temporary schema first. So it writes the data in JSON into these tables, and then it merges the JSON into its target table, and it flattens it out for you as well. So it normalizes it. So you get tables with columns. Whereas in here, it's all JSON records that are within that. I'll just open one up to kind of show that to you. And let's go to SG Meetup. Next star from let's try that one. I think it's still syncing, so we're not going to see any results there. And let's just refresh. Yeah, it might take some time for records to start appearing, but it's going to be JSON, I promise. That column there, Airbyte data, will hold the JSON records. All right, cool. Any questions? Yes.
Yeah, I just want to ask, like, can it also handle use cases wherein, for example, I'm using a third-party product, I hit their API, download CSV, and I want to put it in my any database like Redshift, Postgres, etc.
So your CSV probably has to already exist in some kind of file storage that you can query. So don't know if you can try to build a custom connector, I guess, to try to handle that use case. But most of the time, you've got already CSV in an S3 bucket somewhere that you want to query, or you're just querying the REST API directly. So the REST API will return you back JSON results, and then you can use the JSON and flatten that out into your warehouse. Does that answer your question? All right, thanks. Any other questions? Yeah. How many vendors support CDC out of the box? Yeah, great question. So I think most of the common databases support that. So like MySQL, SQL Server, Postgres, Oracle. Yeah, I would say most, but then there are probably some that don't. REST API endpoints, that is purely dependent on whoever is building that, whether they provide you the full history. Does that answer your question? Cool. Cheers. Oh, CDC, great question. So CDC, is it just used for batch or can it be used for streaming? Yeah, so both. CDC gives you transaction history. It gives you all the events. Now, how you process those events is up to you. Do you want to query that on a batch basis or on a stream basis, right? Batch is always obviously easier because you don't have to think about how do I push the events out. But if you want to stream the events, you can. There's a tool called Debezium. It's a Java tool that you can put on the same server or connected to the server where your database sits. And Debezium will listen to the transaction log for those events and write it to a Kafka queue so that you can, or topic, so that you can query it from there. Then it's purely event from then on. Yeah. Another question? Yes. Yeah, great question. So how does Microsoft SSIS compare to this, or is it not comparable at all? So SSIS is a fully fledged ETL tool. So it does the extraction and loading and also the transformation. It's mostly GUI, meaning it's like graphical user interface. You drag and drop the actions. Now, what SSIS doesn't do very well is the metadata-driven approach. So you saw me sync Airbyte data. There are like, I think, 20 plus tables I synced across. Now, Airbyte and tools like Airbyte will be able to figure out the columns and the data types it needs to map to in the target system. Whereas something like SSIS, you need to write that logic yourself. Yeah. Yeah, last question, yes. Right, yeah. So the question was, what makes Airbyte different from existing other data integration tools like Fivetran, for example? So I'd say the big difference to me is that Airbyte's open source. And so they have a whole like marketing spiel about like how there's a long tail of possible connectors in the world, right? There's an infinite number of source systems and REST API endpoints that could exist. Now, can a vendor build connections to all of these? The answer is no. So that's where they kind of say, oh, if we make it open source, people can build their own connectors and make it open source for other people to use. That's what they try to differentiate themselves as. Truth be told, though, it's not. I don't know, like you can also build custom connectors in Fivetran using AWS Lambdas. So yeah, cool. All right, so let's move on from here. All right, so now we've got data landing into the data warehouse. So what do we do with that data? This is where data modeling comes in. So data modeling is all about putting structure to our data. And there are usually two different phases of data modeling. The first is the staging phase. How do we make data structured in a way that is useful for us as data engineers, so that when we work with the data, we can be very productive with that? There are two different approaches we can use for this part of the data modeling process. The first is called Inman. Bill Inman wrote a book in the 1990s about data warehousing. And in his book, he put forward a thesis or a suggestion that, look, we should be copying data direct from source systems and keeping the same schema that the source system provides us. So typically that schema or that shape is third normal form. So if you look at database normalization theory, there are different ways we can try to structure the data so that it's very fast on transaction and very little duplication of records. So that's the third normal form. So what Inman said in his book is that, all right, the data warehouse, that thing right here, that should be third normal form. And then the next step is creating a data mart, which is where you then apply some kind of business logic to your data. Now, Inman doesn't actually suggest what modeling approach you use for the data mart. He just says you should be thinking about data marts. So we'll come back to the data mart point later. And the other approach for data modeling on the staging side is Data Vault. Data Vault came around in the 2000s by a person called Dan Lindstedt. And his approach is, let's normalize the data even more than third normal form. Let's take it to the fourth normal form even. And the reason for that is to create more, I guess, separation of data and supports. I guess for me, the main use case it supports is that if you have a company, you're in a company that does a lot of acquisitions, and you end up with duplicate systems, like you have a CRM A, CRM B, CRM C, HR system A, B, and C, then maybe something like Data Vault is good for that, because you can quite easily create one instance of HR and then link all those different HR systems together. But it's very complex to do, I would say. So be careful of that. So that's on the staging side. That's how you make data good for data engineers. The next part is now how to make data useful for end users. And that's going to be dependent on how the end user likes to consume your data. Now, a very popular approach is Kimball's approach. Kimball wrote a book again in 1996, and you may have heard of star schema, dimensional model, facts and dimensions. That's this approach right here, where you're creating a fact just represents a business process, like, creating a work order, selling a product. That's a business process. And surrounding that business process is context, like who am I selling the product to? What is the address? So those are what we call dimensions. So that's Kimball's approach. Now, the last approach we're going to chat through is one big table. I think Google came up with that term, I believe, but it's been around for like ever. If you use Excel, you know one big table. You do lots of VLOOKUPs, and you end up with a very wide table. So that's one big table here. And historically, it's not a good idea to use that because, storage costs is expensive, and processing stuff is going to be very slow because you've got duplicated data in memory. But with big data compute, it's now possible to do this approach as well. And so some tools might actually prefer to use a one big table format. So if you look at tools like Tableau or Preset, they like to have very flat tables to consume. Or even if you're doing some kind of export of data to another tool like Salesforce or something using Census, they prefer it in flat format as well. So yeah, it depends on your use cases. So what I would say is, in real world, like in the real production scenario, what you choose is going to be very dependent on your use case and your consumer products. So you might use a combination of tools. It's not one or the other. It's this and, like Kimball and one big table, for example. So in places where I worked at, we like to use Inman for the 3NF, the normal format in staging layer. And then we model it in Kimball. And then finally, if there are use cases that needs flat tables, we create one big table over the top of Kimball's dimensional models. So we end up using all three of them. I don't have experience using Data Vault, but I hear that if your company does acquisitions and lots of duplicate systems, then you can put Data Vault as your staging layer instead. That's the data modeling concepts. Any questions on the conceptual side of things? Cool. So that's the theory about how we need to structure data. But then what do we use to actually perform that structuring of data? How do we transform the data? So this is where we're going to talk about tools and compute. All right, so considerations are data volumes. How much data do you have to process? Do you have big data, as they call it, or small data? What tools are your developers in your company familiar with? I think most people here are familiar with SQL. Show of hands if you use SQL. Okay, keep your hand up if you use Python as well. All right, that's a 10% drop. How about Scala? All right, it's a 50% drop. So it depends on what tools you use in your company. As a rule of thumb, everybody knows SQL. So try to use SQL. it makes everybody's lives easier. It's like a common language amongst data people. The other last thing, second last thing is price performance ratio. So how much performance do I get for every dollar spent? And then of course, we have support as well. So there are different approaches we can use here. I would say I want to stop making differentiation between warehouse and lakehouse. To me, it's the same thing. It's just a different implementation to achieve the same outcome. So the outcome we're trying to achieve at the end of the day is we want to create analytical modeling for our data. How you do it is up to you, but here is just my own way of thinking it. But lakehouse is where you have separate storage and compute, where you might use an S3 bucket with Parquet files, and then you can use some kind of compute, like Pandas can read S3 using PyArrow, Spark as well, of course. And that's going to then allow you to transform that data. Spark has SQL APIs as well, so you can still stick with SQL if that's what you're used to. And then on the warehousing side, we can write SQL using any one of these popular compute engines like Snowflake, BigQuery, Redshift, Synapse from Azure. But more recently, we're moving to this thing called DBT. So show of hands again, DBT, how many of you are using it? Oh, just 5 hands. Okay, that's surprising. So DBT is a nice framework. It's a Python framework designed to make data transformation very easy. I would do a demo of it so that you can appreciate how easy it makes transformations going forwards. Let's jump. Yeah, I'll do a demo now. So let's jump in. All right, so I have VS Code open here. And this is my project I'm going to be using to move data, to transform the data to get to that staging layer. And then after that, to get to that serving layer as well. So that's what we're going to be doing in this demo. You can see in my project, I have a couple different folders there. I have a folder for documentation. I have a folder for orchestration as well, which we'll come back to. I have a folder for transform. So transform is what we're doing. So I'm going to go into transform. And within that, I have a subfolder for data warehouse. And within data warehouse, this may look very alien to you, but to those who use DBT, this is a standard DBT folder structure. And what's within that is a couple of useful things. First of all is the DBT project config file. Not very important, but this is just controlling some environmental setup that you use. But what's more useful is the profiles. Profiles is a thing that holds your connection string to your data warehouse. So here you can see I'm connecting to the Snowflake data warehouse in line 11 here. So that's to Snowflake. And then it just contains the connection strings like account details, database, and password details to my Snowflake. I'm going to change this to SG Meetup now. So that's the schema that we just wrote to, correct? We use Airbyte and we put it into SG Meetup. Now that the setup is done, we're going to look at models. So here's the models. Models just represent data transformation steps. Right? So every time you're running some kind of transformation script, that's going to appear in the models folder. We're going to start off with sources. Sources just basically maps to the sources that have been ingested or your raw layer in your data warehouse. So basically what this maps to is what Airbyte has created. So Airbyte has created, let's see here, let's refresh that. All right, Airbyte has created all these tables, actor, address, city, country, yada, yada. So what you find here is actors, address, category, and so on. So this is just mapping to those tables, sources. Then the next layer is our staging layer. So our staging layer is how do we clean that data up? How do we deduplicate data? Or how do we rename some columns? I have to admit, I was pretty lazy. I didn't go and actually rename any columns. I just did a select star. And here it's using a syntax, a Jinja syntax to help us to create a DAG later on. I'll show you what that is. But by doing this, we can create a lineage graph. And then lastly, we have our serving layer. So this might look familiar again to those that are using dimensional modeling. So if you have used dimensional modeling, you will see this is the dim customer, dim date, dim film, and then my fact table. I just have one fact table here called fact rental. Now, with DBT, I can actually do a lot of the best practice dimensional modeling techniques. So if you study dimensional modeling, actually maybe I pause. How many of you do dimensional modeling? Just a show of hands. Oh, 3 hands. Okay. All right. How do we model data today? What do we do, folks? Do you use any techniques to model your data? No? Anyone? Sorry? Didn't catch that. Oh, okay, got it. So the data modeling is just to how do you structure your data for user study? What do you use? Yeah, SQL is like the tool, I suppose, but there's actually structure you can put the data. Yeah. Okay. Oh, good. So yeah, sounds like we don't model. That's okay. So you just create data. I'm guessing for whatever use case you're supporting. So maybe it's a one big table or something. But the point I want to draw across is that well, if you use dimensional modeling, you would know how challenging it is to build surrogate keys. And so dbt has like plugins you can use to easily create surrogate keys. All right, but that's enough for dbt. What I want to show you now is how easy it is to actually create a model, create a whole transformation lineage. So I'm going to jump into my terminal now. And I am going to run some commands. The first command I'm going to run is dbt docs generate. Oops, cd into this folder. dbt docs generate. Okay, sorry, I already did that earlier. I'm just going to go to the place of my browser where it is. Okay, here we go. So this is dbt docs. So there's a command you can run in dbt command line that once you've created a dbt project, dbt gives you this just by creating the dbt project. And what it tells you in this thing, there's a lot of information here, but on the left-hand side here, it tells me my project. And you remember the DW folder? If I expand that and expand models, remember how we created staging and serving? So we can expand those as well. And we can see all the details of our models there. Now, if you've been a very good boy and girl and use dbt's descriptions and things like that, then if you click on the model, you can actually read the description of the model itself if you put in any descriptors. I haven't done that, so model is not documented. That's my bad, right? Now, the very useful thing that dbt provides is a lineage graph. So if I click on the lineage graph now and remove the filters, sorry, oops, let's just zoom out a little bit more. Full screen. All right, there you go. So, okay, so it's a bit hard to see here, but this represents all the data transformation that dbt has detected, right? So the green nodes there represents the sources. The blue ones represents any dbt models I've created. So we've got raw, we've got staging, and then at the very end, we've got the facts and dimensions at the very end here. Okay. So if I wanted to understand what is dimension film made of, I can click on dimension film and it will show me the child models that was used to create this thing. All right, that's the lineage graph. So now that the point of me showing you this is to show you that dbt understands the lineage of your data. It understands what transformation needs to go first, second, third, and fourth. So with that, I can go and run a command called dbt run. Oops. Cancel here. dbt run, or maybe better still dbt build. And I'll show you what happens when we do that. Okay, so it's running some tests. I didn't show you tests today in the interest of time, but so dbt has a test suite that's built out of the box. So you can quite easily write tests on your data and run them in the correct order as well. But what I want to show you here is that dbt has gone ahead and built the models that I've created, all the different SQL files, and it's done it in a correct order as well. So you can see here, it's gone and done the staging models first. Where is that? Yeah, somewhere around here is staging. Yeah, see all these staging, STG represents staging. It's gone and created all the staging models first before creating all my facts and dimensions because it understands the dependency graph. Oh, and I have a failure again. But that's okay. I'll ignore that. Any questions? Yes. So the question was, does dbt only support structured data? No, if you have data as JSON in a warehouse, so you know how you can like have a column in your warehouse table, and you can just like put every JSON event or JSON record, you can just store the whole JSON inside one row. then it's up to you to write the SQL to normalize that. So if you're using something like Snowflake or Postgres or BigQuery, they have very good JSON support. So you can actually go in like key value pairs and find the exact things you want. So you can still process those events using JSON. Yeah. Correct. That's a great question. DBT is built purely on SQL. Yes. Yeah. Great question again. So the question was, if DBT is only SQL, then why do we need it when we are using something like Spark where we can write any logic we want? So the reason behind why DBT was created is to provide some kind of like paved path to how to do modeling in the best practice. So if you give people all the options they want to choose, then what's the right way to do things? What's the best way to create transformations? Because if you're in a very large organization, everyone will do transformations differently. And when people leave, you got a monster of a code base to maintain. But DBT structures everything so that everybody's using SQL, everybody's doing things in a certain way. So that's, I guess, the pros of it, but there's also like some cons, obviously. Like the trade-off would be that you can't do it, like certain things like Spark, for example. You want to write Scala, you can't do that on DBT today. They recently launched Python on DBT, so you can start to build models in Python as well.
So, regarding this lineage which you talked about.
Yep.
Here you are saying that we can have multiple tables when dependency created.
Yep.
Generally, let's say if you are using Spark, so we use Airflow and do that dependency.
Yes.
Like this in DBT itself.
That's another very good question. So your question was, in Airflow, which is what I think most people here may have used, we define dependencies using that, like, node 1, then node 2, then node 3, right? It's very similar. So the difference is that DBT uses a more declarative way of defining the lineage, whereas Airflow is more of a, I forgot the word, but imperative. You tell it what order you want things to execute, whereas DBT infers, it looks at your code using the ref functions. So I showed you earlier, maybe I didn't show it, sorry. But look at this ref function here. So this ref function here represents the table I'm consuming from, right? My dimension is built from a staging table. So this is the staging table. Now, because you've written it that way, DBT creates a DAG for you. Whereas Airflow, you need to say step 1, step 2, step 3 using the double arrow symbol. Yeah, last year.
How do you like scalability and everything in DBT?
Scalability, in what sense?
Is it a distributed way or how does it work?
What do you mean by distributed?
For example, if I want to run, like suddenly today I have to run a lot of data. Generally, I run 100 GB, but today suddenly I have to run 200 GB, right?
Yeah.
That scalability, how does it?
Yeah, great question. So, okay, so scalability in the sense of increasing data volumes, how do we deal with that? So DBT is a SQL framework. It's up to your data warehouse engine to process the data. So if your data warehouse engine is Postgres, then you will hit a natural limit, upper limit at some point. But if you're using something like, say, Snowflake, where it's horizontal, scalable, or BigQuery, then you can process very fast increasing amounts of data. The other thing that DBT does as well, it's got some logic to handle incremental transformations. So rather than doing a full transformation every single time, like read all the data from this table and then created my staging table, my dimension table, it can just take the new records as well because it can handle incremental logic. So you can use watermarking and things like that. So it helps with the scale issue as well. Yeah. All right, last question. Yes, and we'll move on. Sorry, can you repeat your question? Oh, so the question is this different from SQL Server? So this is a tool that sits in front of your database. You can throw any database behind the scene. It can be SQL Server, it can be Postgres, it can be Snowflake. Yeah, but yeah, I don't know. Does that answer your question? Yeah. Cool. All right. Sorry, we have to move on just in the interest of time. Am I good for time section? All right, cool. I'll move on to the last component, which is orchestration, which is, I think, very cool and interesting. So, and I can come back to questions later as well at the end. All right, so that was data transformation using DBT. Now, the next thing I want to show to you is data orchestration. So you saw that I have an Airbyte thing, and then I have DBT as well. How do I link those two things up together? So what I want to be able to achieve is that when Airbyte finishes, I want to kick off DBT. So now this is where we're bringing our data orchestration tools. Someone mentioned Airflow. So yeah, Airflow is a very popular one. It's been around since 2014. Very, very famous tool built by a guy named Max from Airbnb. And since then, there are a couple of other lightweight tools as well that try to fix some issues that Airflow have. And one of the big issues that Airflow has is that it uses a lot of different services like Redis cache and Postgres and a bunch of things in order to just get data orchestration working. So tools like Airbyte and Prefect came out after Airflow to address those issues. So what are some What are some considerations when you're picking a data orchestration tool? So as always, integrations. Because you're orchestrating dependencies between systems or services, then you need to ask yourselves what service integrations are supported. So does it allow me to trigger DBT jobs? Does it allow me to connect to Airbyte and trigger an Airbyte API call? Things like that. The other one is proficiency as well. So you'll find like most data orchestration tools are actually written in Python because developers love Python. It's easy to use. Whereas some other tools, I think Luigi or something, I think it uses something else, I'm not sure. And like Argo, for example, is all YAML. So it's nicer for the infra folks that like to write YAML. Then triggers is another new thing as well, or very, well, not new, but like it's a big consideration is we can trigger jobs now using different patterns. So maybe a file lands in S3. As soon as that file lands in S3, we can now trigger the whole ELT pipeline. Another one that's cool is asset-based triggers as well, or sensor-based triggers. We can talk about that some other time. Yeah, that's the main considerations. What I'll do a demo now is Dexter. It's written by a guy from Facebook, and yeah, I think they released 1.0 this year, February, and so there's a cloud-supported version of Dexter as well. So Dexter is fully open source. So I'll just put this down. All right, so I'm just going to launch Dexter first. Okay, hello. All right, so here we go. This is Dexter. Dexter is just a data orchestration tool that allows you to specify dependencies between tasks. Now, what I've done is I'm going to go out of my transform folder, and I'm going to go into that orchestrate folder that I mentioned before that holds my orchestration scripts. And within that, I'm going to go into ELT and go into this file called Python. I did a very basic one. This is just very messy, but Python repository.py contains the definition for this job, for this data orchestration pipeline. So what I've done here, the main thing to draw your attention to is this little bit here in line 18. So there are a couple of steps before that. I've created a connection to Airbyte, and I've created a connection to DBT. Now that I've created those connections, I've stored those connections as operators or steps inside of Dexter. Sorry, confused with the names. And now what I'm saying is I'm creating a dependency using this Python-y syntax where I'm saying run Airbyte first, and then after Airbyte runs, then run DBT. This is just how you define dependencies in Dexter. This is how you do it. Right, so this is the dependency defined. I can now go back into my browser window and look at the graph here. So the graph here shows me that Airbyte will run first, followed by DBT. So it replicates what we saw earlier in code. Now I'm ready to run my job. I'm pretty happy with this setup. I'm going to go to the Launchpad and press Launch Run on the bottom right corner. Just hit that. And it takes me to a different screen. And in this screen here, I see Airbyte sync is triggered. I can verify that Airbyte is running because I can go to Airbyte, go into connections, and then I can see that a new sync was just triggered at 8:04 p.m. So that was just right now. Dexter is the thing that's running Airbyte. And when Airbyte completes, I don't want to keep you all waiting too long, so I'll just show you, like a chef, you always prepare the finished meal. So I think I have a finished meal somewhere, or maybe I don't. Jobs, job runs. Oh no, sorry, this is a new run of it. I don't have a cached job. But yeah, when it finishes, it takes about 3 or so minutes to run. Let's go into here. What you will see is that after Airbyte finishes, you will see that DBT will run as well. But the one thing I want to show you that's pretty cool is logs. So why do we care about using data orchestration tools? Yeah, the linking. But the second thing is logs. So when something breaks, I don't have to go to Airbyte and read Airbyte's logs. I don't have to go into Airbyte here and scroll through the logs to figure out why is something failed. I can just stay within Dexter, and Dexter has the log streaming from Airbyte in real time as well. So you can see that all the logs are kind of showing up here from Airbyte. Cool, I think that was it. So I'm going to wrap things up. Any questions on data orchestrators? Yes. No, it is part of Airflow as well, I believe. Oh, right. Your company doesn't push the logs. Okay. Yeah. Yes. What will be the pros and cons of each? Yeah, pros and cons between different tools like Airflow versus Dexter versus say Prefect. Yeah, lots to talk about. I think like two things we can talk about is like people who know how to use the tool. Airflow has been around longer, so you find more people who know how to use that. The other one is I guess the management of infrastructure. Airflow is very hard to manage in the infrastructure if you used it before. You can try to use those managed services, like MWAA is the thing that AWS provides. And then there's one called Astronomer. Yeah, but very expensive. I think, yeah, it's quite expensive. But yeah, so those are options as well. Whereas Dexter is a lot easier to manage in terms of infra. It runs on Kubernetes. They have Helm charts as well to make the deployment very easy. Yes, last one.
So this entire demo was regarding ELT.
Yes.
So in many companies, we are currently using ETL.
Yeah.
Should we just push towards ELT, or there are some cases where ETL is better than ELT?
Great question. So you're saying that in his company, they're all using ETL. Should we start thinking about moving to ELT? What are the benefits of moving to that new approach? So have everyone heard of the term data mesh? Understand what data mesh is? So data mesh in a nutshell is about enabling more people in an organization to make decisions or to get insights from data. Now, ETL is designed for data engineers. So if you know how to code, you can do ETL, right? You can continue doing what you do. But how many engineers are there? Like 10, 20? At Canva, for example, we have a data engineering team of 12 people. So I'm one of the 12. But we have 100 of data analysts in the company, and they all write SQL using DBT. Now, we're able to do that. We're not able to hire 100 data engineers, but we can hire 100 data analysts, right? And so that's one of the reasons why we moved to ELT, because ELT allows us to move data into the warehouse and then give the data to data analysts. Like, here you go. Here's the data warehouse. Here's DBT using SQL. Write your queries and transform data yourselves. Yeah.
Future then data engineers will do job.
Yes. I would say the job description is changing. Yeah. Last one. Yeah.
Yeah, so currently we are actually having Matillion. So the background of Matillion is something like there is ELT's job. So we are thinking of shifting the data warehouse and data lake from one place to another. So right now we are having like maybe 60 pipelines or like 100 pipelines that is running per day on Airflow and also like Matillion. So the question is, if we are actually doing the migration with the ETL to the endpoint of having a different warehouse, how do you think that the process should be done?
Right. So we're talking about like tooling migration, like from an old tech like Matillion to something that's more modern and a new architecture change. Yeah, it's going to be very challenging. I've just for context, I consulted to a different company before Canva, and they've been trying to move off Oracle Data Warehouse and Informatica for the last 5 years, and they haven't moved off Oracle Informatica yet. So look, I think the question is how much logic and spaghetti do you have, like spaghetti logic do you have, right? If it's come to a point where everything is too spaghetti-like, you can't make sense of it. Like the ideal thing scenario is that it's very straightforward. All right, this SQL logic, let's replicate that in this other tool. But if it's a spaghetti mess, then I think you got to start thinking about cutting off like the rotten limb, so to speak. Maybe it's time to move on to a different thing, and there will be a period of time where the service will drop. Like, you kind of get the same insights for the dashboard that you're using before stops running. And then you just say, but we have this different thing here it's not perfect, but it's getting there. So that's, I guess, the approach. Yep, cool. So just wrapping up, and then we can open the floor for general questions. So the point of my talk really is just to show you the patterns to start thinking about like what you should consider. I'm not trying to like sell you a tool or like recommend any one tool in particular. I'm just trying to show you more of the patterns, but you can implement this pattern in your company using this architecture like Airbyte, DBT, Airflow, Snowflake, or you could do something like Airbyte Databricks using Spark SQL and Airflow as well. Or what else do I have? I think I tried to do a few examples. So Dexter instead of Airflow. And Fivetran as well is pretty cool. Yeah, so I guess the point is that the important thing to understand is the patterns, and then just pick the tool that works best for your use case. All right, I'll end it off here. So I just want to call your attention to Data Engineer Camp. So I run a 14 weeks data engineering bootcamp if you're interested in that sort of stuff. I teach a whole bunch of things from the bare bones basics like low-level programming of Python, SQL, building ETL pipelines from the ground up. So if you like pain, you like pulling your hair out, then the first 2 weeks of the bootcamp is ideal for you. But the point is to teach you the fundamentals so that when we move on to frameworks like Airbyte, Spark, Databricks, Snowflake, then it becomes like, that's why these two exist, because it makes life so much easier. We'll cover things like data modeling, data orchestration. I didn't touch a lot on streaming today, but we do go into streaming quite deeply as well using Kafka, and then we use a real-time database called ClickHouse as well. And yeah, we learned some stuff like CI/CD, which is pretty cool. Find out more, feel free to go onto my website, dataengineercamp.com. The next cohort kicks off on the 9th of January, 2023. And just say you've been to the meetup and we'll give you 20% off to the bootcamp. Just so you know, like the students that are with us today, we have 24 students this cohort from 6 countries. And they work at places like Microsoft, Tencent, Fidelity International. And so, yeah, they're all really interesting people that want to like change their careers into more of a data engineering role from data analyst or software engineering. But yeah, that's it from me. Happy to take any more questions. Yeah. Sorry?
How does pricing work?
Pricing in each typical layer. Okay. So data ingestion depends on either you're paying a server, meaning you run your own infrastructure, or you pay a SaaS, so you're paying per record ingested. Yeah, you just got to look at the pricing page. If you're doing huge volumes of data, it's probably better to do your own infrastructure. And then you need to hire more engineers, but it might be cheaper to run your own infrastructure. Like for example, at Canva, I mentioned we had 1 billion events. We don't use Fivetran for the 1 billion events because that would cost us $1 million a month. So this, not feasible, not in the ballpark. These things we can afford. So we run our own infrastructure for that. But we do use Fivetran for third-party sources. So when we're ingesting data from Salesforce, from Facebook ads, we use Fivetran for that because like I don't want to make the connectors. I don't want to maintain those connectors. It costs me like, a salary amount times, how many hours per week to maintain those. So it's cheaper to just use Fivetran. From a compute standpoint, from Databricks or the data transformation side, the question is how frequent are you running the refreshes? So if you're running it every 5 minutes, then that's going to cost you a lot of money. The other thing as well is how you're running those refreshes. Are you running it full, meaning you're recreating the tables every single time, or are you running it incremental? Incremental can work, but you need to have certain conditions like primary keys, incremental columns to support that approach. And Airflow and Dexter. So the nice thing about the new tooling these days, Airflow is all like you're going to pay a fixed rate. It's just server costs. But if you use something like Dexter and Prefect, they have serverless offerings, so you need pay when you're using Dexter or Prefect. So it's much cheaper as well. Hopefully that answers your question. Cool. If there are no other questions, I'll end it here, and I just want to thank. Yes.
So DBT works very well on the cloud if you're working with something like Snowflake that can scale horizontally forever, so it's not going to break your current batch, even you have 100 analysts right in DBT, right? But if you were on-prem, where you have limited resources, for example, for your warehouse, and you have to compete with IT jobs and core batch, would you make different considerations and use something that maybe executes the compute outside of the capabilities?
Yeah, so the great question. So just to rehash your question, when you're on the cloud, you have elastic scale. You don't have to worry about compute or resource restraints. When you're on-prem, you have to start thinking about resource restraints. What considerations? How do we make it work on an on-prem scenario? So I would say, firstly, it's not just an on-prem thing. Cloud also has restraints. If you're using something like a Redshift cluster, where compute and storage are coupled, then you're going to hit restraints nonetheless. So the consideration here is to decouple your storage and your compute. So on-prem, yes, run your own file system and use Spark. Now, you can provision as many Spark clusters as you want, right? There's no limit to how you guys want to do it. So you can have a Spark cluster that scales out horizontally, but you can also have multiple Spark clusters. You can have one Spark cluster for team A, another Spark cluster for team B.
So if you wanted to use DBT on-prem, would you couple it, say, with a Trino or some query engine that can execute on the...
You can use Spark. You can use anything that supports SQL today. Yeah, DBT Spark SQL is what you use. So Spark is the compute engine, and there are several different language or APIs you can use to interact with Spark, like Scala, Python, and SQL. Yeah. Cool. All right, with that, I'm just going to end it here. Thank you, everybody, and I'm going to hang around for a bit more and hope to chat to more of you. All right, thanks, everyone.
Thank you, John, for the talk, and it's a great turnout today. And thank you very much for coming. I'm Teck Chun, and there's Ravindra there. We help organize the Data Engineering Singapore meetup. And this is the last meetup for this year, so we'll be back again in January on the topic on DBT, right? So hope to see you all again soon next year. And till then, have a great festive season. Stay safe. See you guys next year. Right? Thank you.